Good morning, good afternoon, and good evening. I hope all of you are safe and sound. My name is Lumal Mana. I am a petroleum engineer currently working as a field engineer with Halliburton, Iraq, and I will be your moderator for today's session. On behalf of Arab Oil and Gas Academy, I would like to welcome you all to the last webinar of Effective Python Programming for Exploration and Production, given by our special guest speaker, Engineer Yohanes Nuwara. Our guest speaker is now working as a distributed acoustic sensing geophysicist in the RITE Institute, Japan. He holds a bachelor in geophysics. He had achieved outstanding achievements in many places. One of them was minus CO2 challenge by Equinor and EIGE in 2018. He has several high-ranked publications. One of them is about integration of rock physics, time-lapse seismic modeling, and geomechanics for CO2 storage, in which he will present in the 82nd EAGE Annual Conference this October in Amsterdam, Netherlands. He had been working on open source Python programs for geoscience and petroleum engineering since 2020 and had been teaching to more than 1,000 SPE students and professionals worldwide. In his free time, he loves writing blogs in towards data science media publication, involved in his Python for Geoengineers community in Telegram, reading biography books, and doing sports. Now, before we begin, let me remind you to leave your questions in the Q&A section box down below. And Engineer Johannes, it's a pleasure having you here again with us. Welcome, and the mic is yours.
Okay, thank you, Luma, for your introduction. Hello everyone. Welcome to my very last test session. It's been a fourth session on effective Python programming. Well, for me, it's a quite rewarding session for these four sessions because I'm really glad to meet all of you, some aspiring engineers and scientists in petroleum engineering who would like to learn about Python. And I hope that after you have already followed all of the sessions that we have gone through, from basics of Python, and then production data analysis in session 2, and then exploration data visualization in third session. And today's session will be the decline curve analysis. I hope you can apply these skills, Python programming skills, for your study, for your work, or for your research. But for today, this topic is actually quite interesting for some reservoir engineers because the topic is decline curve analysis is a quite important topic for reservoir engineering. Why? Because DCA, as we call it, is a useful tool for us to forecast production in the future. So if you are given a production data that we have been reviewing in our second session about production data analysis, today we will again use the data that we used in the second session. For this session, we'll use decline curve analysis to forecast future production rate. So here you can call it DCA, and basically what we have covered in the second session is a real production data of a field in the North Sea. The name is the Fold field. And one of the wells, we just analyzed only one well there, which is the F14. We obtain this result from our production data analysis. If you look at this graph, maybe I hope that some of you have already explored about the source codes, the data and the results, because yesterday last session, I have already announced about the links to access the source codes. If you haven't seen one, here are the links to access the source codes. And if you go to the second session, you still remember that we have already discussed about this data, okay? As you see in this data, in this graph, there are two colors here, okay? The orange color represents the oil production, and the blue color represents the water production, okay? But as you guess, the decline curve analysis, it is only used for oil and gas, but not water, right? Because water is considered as a non-economical um, 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 commodity when we run an oil field. We only focus on oil and gas, okay? But here, if you see in this graph, the representation of water is quite important because it can tell us whether about the aquifer, is there any influx of water in our reservoir, or at a certain time they did water injection, because as you see here from 2010, you will see an increase in water production because they, as far as I know, they did water injection to boost the production of oil and gas in the full field, okay? And if you see in this orange curve here, you will see a very, very familiar pattern, which is a curving, okay? A curving production here, okay? The production rate is decreasing from 2010, and the decrease is very typical. Okay, what we will today we will discuss about what we call as the ARPS decline curve types. ARPS decline curve types is a decline curve analysis first proposed by an engineer named ARPS, J.J. ARPS. Okay, in 1942, he published a paper in AIME about decline curve analysis, and he found out that there are generally three kinds of decline curve types: the harmonic, hyperbolic, and the exponential. If you see in this graph, these are three kinds of typical decline in any producing oil and gas fields. In this harmonic decline, okay, you can see this formula. Okay, this formula represents Q is the production rate and DI is a initial decline rate. Okay, and here in the hyperbolic one, there is another parameters with which is B. B is the decline exponent, and then the Q1 is the initial production rate. So DI is initial decline rate, and Q1 is the initial production rate. So don't you have to understand this and don't be changing this, because DI and QI or Q1 or Q0 commonly is really prone to have error with this kind of formulation. And then the green one is the exponential. And if you see here in this curve, the hyperbolic curve is a general curve. Why? Because the B, the exponent, the decline exponent is from 0 to 1. So it can be 0.1 or 0.9 as long as it's between 0 and 1. So actually exponential and harmonic decline is actually hyperbolic. So when the B equals 1, it becomes harmonic. And if B equals 0, it becomes exponential. And the rate of decline for each curve is different. If you see here, the exponential decline has a steepest decline compared to hyperbolic and harmonic. Okay, and basically this is the equation, but you have to focus on this red curve, red hyperbolic, because this is the general. So today we will mostly talk about this type of curve. Okay. So let's go to our source code. This is our source code today for today. Okay. And we will use the same data as we have used in our second session. This is our data. Okay. This is the link of our data if you type it in your browser. You will see the data. There is a production data we have already analyzed in our second session, where we make a histogram and other stuffs, statistics about the data. Okay. Another function that we will obtain here, we will use, is a function that is called the DCA. So I have prepared this function in my GitHub because I contain most of my functions in my GitHub. You can free to follow some projects in my GitHub. I have projects about reservoir engineering, formation evaluation. So maybe if you want to see the function, what the function looks like, you can just copy and paste as we have already done in our third session for our natural fracture analysis. Here is our function, okay? And if you go to my GitHub, you can directly go to this link, PyReservoir. So PyReservoir is my it is my repository where I just made lots of models in reservoir engineering. Maybe you want to use some of this for your study. For example, I have a PVT correlation, volumetric mapping, and lots of other stuffs here, including the decline curve analysis. Okay, including this well test analysis. If you are reservoir engineers, you must be familiar with all of these things that I show you in this GitHub. Okay, so just directly go to our source code here. We can run this, okay, to get the function. Once it is run, you can see again in this panel, you can see this two functions here. Okay, we will use this function, which is called the ARPSFit, and another function is the remove outlier. Okay, so this is ARPS bootstrap remove outlier. Okay, we will use these two functions. And as usual, we import our the libraries. First one is NumPy, Matplotlib, and Pandas. Okay. plt and import pandas as pd. And then we also import DCA. Okay, so we have DCA. From DCA, we import two functions, the ARPSFit and the remove outlier. Okay. Okay. So, and then we define the link as usual. This is the link to our data. We run this. Okay. We get the path. Okay. It's quite simple. And then we start to read the data. Okay. Using pandas. So remember, whenever you receive a CSV file or the Excel spreadsheet, you can open it with Python using pandas libraries. And what function will you use? Okay, what function? You will use a function that is called the read CSV. Okay, so here I define a new variable called df and then pandas read CSV. And then define our link. This is our link. And then if we see the data, okay, so this is the data, okay. So it is just the same as our data in our second session when we talk about production data analysis. Maybe you want to inspect the 21st 20 rows. Okay, it's more, I think just 10 is enough. Okay, this is the data, and from this data, maybe it's if it is not a Zoom session, I can freely ask to you the participants about any question I want, but here maybe I just leave it like we have a date production. So what data we'll use from this data? It's the time. Okay, so this one, And then the second is because we would like to do decline curve analysis, we will use the bore oil volume. So this is the production rate. Okay. So in these two data, don't forget to convert this column, this first column, into the pandas datetime format. We have already discussed about this in our second session. So whenever we read a CSV file, we have to take a look at the date column first. So we have to focus on the format because this is not a format recognized by Python. So we have to convert this into Python format, okay? And the way we have to do this, we use the what is called as Panda to datetime, okay? I hope you still remember this, okay? And the first thing before Panda to datetime, I define what column I would like to change or convert. This is the one, date production, date PRD, and then equals Panda to datetime, and then define again our column, and then we pass the format, okay? Because as you see here, this is the date, okay? So the date corresponds to this symbol in pandas, and then this is April, but there is not a full month. It is only 3 letters, APR, so it is declared as B, okay? And then for the year, it is only 2 numbers, not the whole numbers. It's 2014, so it's Y, okay? And then if we print our data, after conversion, it has been already converted into Python format, okay? So don't forget, anytime you get a CSV file or any other file you want to analyze with Python, you have to first convert the time column into Python column. But how do I know the symbol for this format? Actually, you can browse in the strf time in your browser. It is available in Google, so you can Google it, how to convert the certain format. For example, it is not this format, but another format. For example, the year comes first, and then the second is the month, and the last is the date. So it will be a different format for that. But you can browse yourself in the internet. It is just available in the documentation. Okay. So we have done converting our time column. So it means that we have already set for our data. We are ready to do our next analysis. Okay. So because it is not comfortable to see all of this data, because we just use only 2 data from this, the date production, and the second one is the bore oil volume. So we can simplify this data, okay? And also, if you see here, there are lots of wells, but we will use only one well from this data, which is called the F14. So we select the data frame. So this is just similar to what we have done before in session 2. So we just repeat it. Select well. df equals df, maybe df. Okay, df equals. We make a mask first. Our mask is df, which in the NPD well bore name. Okay, this is the well name. We would like to choose only well F14, okay? So we define our well. This is our well 9F14, okay? We have already created a mask for that, and then we just pass this mask, okay? And then, okay, so maybe DF2, okay? So make it different. Okay, so if we print this data, you will see this is it is already been only in the in well F14. Okay, so no other wells in this data. Okay, and then because as I said before, we would like to select only two columns, the date production and another one is the bore oil volume. So we can select only two columns by using this df2 because we have already created a new data frame. So we make a double bracket here, and then we define which column we would like to use, the date production, and then the second one is the oil bore volume, okay? And then if we print this once again, okay, oil bore volume not in index, oil bore volume. Oh, bore oil volume. So it's wrong. It's bore oil volume. Okay. Okay. So this is our data that is ready for decline curve analysis. We don't use any other data except these two data. Okay. So this is the date production, and then this is the oil production rate. Okay. Only for this well. Okay. And then we have to plot this production rate. Okay, so remember we use PLT plot, or we can use another which is called the PLT.step. I hope that we have already discussed here PLT.step for visualization. So I hope I believe that we have already been discussed about this. So we can use either PLT.plot or PLT.step. So I will use the PLT.step. Define our X and Y axis, okay? Because we'd like to plot the production rate over time. So we define our X axis as our time axis, and the second axis is for the borehole oil volume, okay? Borehole oil volume, okay? And then if we plt.show to show the plot, okay, maybe I would like to make the plot little more size 7.6. Okay, oops, maybe a little more 13. Okay, so this is our data. Okay, so this is the production rate. So maybe you would like to define the Y label as the production rate. Don't forget you have to always concern with the units that you use in your data. Okay, um, although it is not defined in your data, but actually you can guess yourself. Either maybe you are handling with oil production rate here. Either it is barrel per day or millions of barrel per day or billions of barrel per day. You have to define it first because it is very very important to concern about the units you are working with. Okay, but because here in our data it is in the unit of barrel per day because in oil production. So we will use this as oil production rate, or I just want to use it just QO, standard barrel per day, or STB. And then for the X label, it is year. Okay. So you have already known that if you handle gas production data, you cannot define it as barrel because barrel is not a unit for gas. The unit of gas is cubic feet. Okay. Or for example, if you are working with metric unit, you will work with cubic meter. Okay, and so this is our data. Okay, interestingly, if you see in this data, there are lots of like it is not a perfect one. Okay, there are lots of outliers here. You can see this is the outliers. You can see lots of outliers here. where the production rate decreases to zero, and then this one decreases to zero. It is not the data is not as perfect as we want to as we expect in this data, because there are lots of outliers here. And before we are doing decline curve analysis, we have to concern with the outliers. Why? Because the existence of outliers in our data will affect our analysis. Okay, it will make our analysis not accurate and not precise. So we have to remove these outliers. Okay, so this is our production data, and then we will remove these outliers from this data. Okay, I have already had a function that is called the remove outliers, and if you want to see the function, okay, you can type help and then remove outlier. Okay, so once again, all of these functions are in my GitHub. Okay, so maybe you want to check in this in my GitHub. There are lots of utilities you can use here. Okay, and once one of the functions is called the remove outlier, you can see here what inputs are required for your function and what is the output. So for any function, you can see the documentation. I have made a documentation, so it's already complete, and you can read it and learn how to use this code or this function. So here for the remove outlier, we need the data. First, we need the data frame, and then the name of our column, okay, and then the window and the number of standard deviation. Actually, this is the method what is called as the rolling average method. Okay, rolling average method is a method to remove outliers by comparing the data with the statistics of the data. Okay, in our second session, we have already discussed about the standard deviation and the average of our data. We use the summary statistics to do that. So using the standard deviation and knowing the average of our data, we can remove this outlier. Okay, so in this input, you have to define how far you will cut the outlier from your standard deviation. Okay, for example, your data has a standard deviation of 2.5. Okay, and you want to remove the outlier of the points that is located very far away from the outliers. Okay, because outliers are the points that is far away from the standard deviation. Okay, so you define the distance, for example, um, as far as 10 steps away from your standard deviation, you will recognize it or you will define it as the outliers. So you have to define those this inside this input. Okay. Okay, so maybe we can try this function. We can make another new data frame new, which is the data frame after we remove our outliers. And then we use the function. Okay, first of all, as you see here in Google Colab is really good. Is a really good idea, because you can see if you make a code, it will automatically print what function that you use, and then also all inputs that are required for the function. Okay, so it is automatically appears here. The first input is the data frame. We have the df2. Okay, and then the column name. So pay attention here. We would like to remove the outliers of the production rate. Okay, so the production rate in our data, the column name is bore oil vol. Okay, so in the second input, we define our column name, which is the bore oil volume. Okay, and then the window. The last two parameters we have already discussed about the number of standard deviation away from mean previously. Another one is window. So actually you can there is no valid number you can use for this function. You can use anything. because you can try it yourself. For example, you want to start with any number you would like. For example, the window is 10, and then the number of standard of deviation is 10. Okay, and then okay, and then if you see this another, it will print us the result after the data have been the outliers have been removed from the data. Okay, so you see here this one. Okay, so bore oil. This is our original data. Okay, and this third column is the data after the outliers. Okay, but you don't have to be worried about this two last columns because it's not quite important. You have to pay attention here. This is our result of the removing outliers. Okay, so and then if we plot, maybe I'd like to go from here. So if we plot the outliers, okay, so later you can compare. Maybe you would like to use another number for this, okay? So we plot the outliers, we plot the result, okay? plt.step df. This is our original data. First, I would like to plot the original data. Okay, I can just copy paste here. Okay, so this is our original data. And the second one, I would like to plot the data after the outliers have been removed. So df new, and then the same date production, date PRD, and then the y-axis is the bore oil volume. But right now, because as you see before, okay, so maybe I would like to show it once again here, df new and df new. So this is our result. Okay, so we use this instead of this. Okay, because this is the result of our removing outliers. Okay, so this is the plot. Okay, so if we plot the two of these ones, okay, maybe I'd like to bring it more larger figure. Okay, just use this. Okay. Okay, so if you see here, okay, okay, so maybe I can make a new label. This is the original one, and this is the outliers removed, and show the legend. Okay, so here, this is the legend of our plot. The blue is our original data, and the orange one is the data after we remove our outliers here. Okay, so if you see here, the outliers here at 0 barrel per day has been removed. But if you see in this plot, it is not a quite smooth graph, okay? So it means that you have to little fine tune these two numbers. So you have to change this number so that at the end you will come up with a really not really but a smooth curve. Okay, so maybe you would like to change it a bit, 50 and then 30 to make it larger. You can see the difference here, right? So it is smoother here. It is already smoother. Okay, but I don't like this graph because it is still the outliers here. Okay, this is the outliers, the outliers. This is the outliers. So it's the outliers have been perfectly removed from the data. Okay, so we can increase it even further. For example, the 150, and then this is 50. Okay, so you can adjust yourself, and you will see here. Okay, it is already smooth. Okay, so this is data that is ready for decline curve analysis. If you have this kind of data, the question is maybe you ask do we really have to remove our outliers from the data, or it is just an option? I would like to say that well, it is not an option because the decline curve analysis will give you an estimate of your future production rate. So you have to be at least certain for your forecast or your prediction. So you have to remove some outliers from your data because the outliers will affect your prediction. Okay, so imagine you have this original data, and then you just directly do the decline curve analysis. You will produce a not too precise and not too accurate decline curve parameters from your data. So you have to remove the outliers. Okay, and again, you see here in this graph, there is an increase in production. Okay, it is not useful here. This part is not important in our analysis, because decline curve analysis, we only analyze the decline, not the build up or the increase of production rate. So we have to remove also this part. Okay, so maybe I'd like to okay, that is yeah, we'd like to remove this initial increase in production. Okay, so using this function, it is simple. You can add trim equals false. Okay, and it will automatically delete or remove the first production increase here. So sorry, so trim, because it is so here you can see the trim equals false. It means that you don't want to remove this part, but you have to. Okay, so you can pass it as true. Okay, and if you will see that there is no initial production increase. Okay, so using this function is quite simple. You can use this function. I've already prepared for this. I've made for this, so you can use very simple. Okay, so first thing, you have to adjust these numbers, and then if you pass this trim equals true, because you should remove the first production increase. So you have to define it as trim equals true. Okay. Okay, so we have already get the data, and then we define our variables. Okay. The decline curve analysis requires only two data, which is the time and then the production rate. So we define the data. Okay. The first one is our time. So date production, date PRD. All right. So and then the Q is the production rate. So this is okay. DF new, and this is our rate. And don't forget to use this outliers remove data, not this one. Okay. So this is our original, and this is after we remove the outliers. So we use this. Okay. All right, so we have already done defining our variables. If you see here, this is the time, okay? And then this is the rate, the oil production rate, okay? Okay, so, and then after we have already obtained our production data, okay, we simply go to decline curve analysis, okay? You don't have to understand the decline curve analysis really from scratch, because understanding it from scratch and doing it from scratch in Python, it is quite too lengthy in time and complicated. You have to understand first the hyperbolic function. You have to make the function first, and then you have to normalize it, denormalize it, and do some pre-processing to the data. So I think in this session, we don't have to cover all of these things because we just have only 1 hour. So it is quite a short time for us to learn all of this. So in this part, I have already made a function, so you can use directly without you have to do it from scratch. Although I have another course previously last year on how to do decline curve analysis with Python from scratch. So I think you can go to one of my notebooks there. I have a notebook where you can learn how to do decline curve analysis from scratch. Maybe you learn it in your college, or you just received a class in reservoir engineering when you have to do a decline curve analysis from scratch. I have a notebook. Maybe I'll show you later after we finish the session. So today we will use an in-house function that is called this help the arps fit. Okay, this is the function that we will use here. Okay, so if you see in this documentation, you'll see this is the input of our decline curve analysis. Okay, and then it will output the 3 parameters. So don't forget when we are doing with decline curve analysis, there are always 3 parameters that we obtain. The first one is Q1. Okay, so maybe we are going back to this slide. So this is the formula, and then there are 3 parameters that we are interested to find. The first one is the initial production rate. The second one is the initial decline rate, GI. And then the third one is the B, or the decline exponent. Okay, so if we run this function, it will give us what is the best estimate of these 3 parameters. Okay, so we can directly do the decline curve analysis. Okay, so we use ARPSFIT, and we define what is our time, which is t, and then q. And then the third input, you have to define whether or not you would like to plot your result. But here, because we'd like to visualize our result, we can pass this plot equals true. And if you run this function, it will automatically do the decline curve analysis. Okay, if we run this, so here, this is our result of our decline curve analysis. Once again, you don't have to understand step by step on how to do decline curve analysis, because I believe that you have already received this in your class, decline curve analysis, and you can do it from scratch using the curve fit utility in Python. Okay, but also I have made this function usable, so every time you can use this to any data you want. Okay, so this is the result of our decline curve analysis for the full field. Okay, and this is take a look at this. There are 4 outputs after we are running the decline curve analysis. Okay, these outputs are our decline curves. Okay, and the fourth output, the last output, is the error of regression. Let me explain to you one by one. Okay, so we are back to this slide. So the shape of our curve is determined by these 3 parameters. Okay, so these 3 parameters control how the decline curve looks like. Okay, and because we have already discussed before, the hyperbolic, the B, is between 0 and 1. But in other cases, like in this full field, okay, we don't have quite same in the theory. Okay, so in the theory it says that it's between 0 and 1, but in some cases I can say that most cases in maybe some unconventional fields I've been working so far, it can produce negative numbers. Okay, so hyperbolic decline can be negative. Okay, so if it is not an unconventional one. Okay, so it can be negative. And then we take a look at this again, okay? Because here we see an increase in water production because they are doing a water production, okay? So it can affect actually this negative number because water production can change the decline. Okay, so maybe if we don't do water injection or any other control from the surface, the decline exponent or b can be between 0 and 1. Okay, and then this is the initial production rate here. So from this, only from this result, we can say that my initial production rate is this. Okay, so this is our initial production rate, and then the initial decline rate is this. Okay, and then if we want to explore more, we can extrapolate for future production. Okay, and then so this is the blue curve. It is our original data, and the red curve is our fit data. Okay, so the fitted regression. Okay, so this is how the decline curve analysis looks like for real data. Okay, so actually for this session, it's just this. Okay, the discussion is only for this decline curve analysis. Okay, you can actually explore more for your own data. You, like, for example, you have your own data. You can try with this function. Okay, and then it will tell us how the parameters or the forecast of our field. Okay, so to recap for our session today. Okay, so we have already know how to read the CSV file, the production data. Okay, this is the production data. We read it, and then we convert. Don't forget to convert every time the time column into pandas datetime format. This is the Python format. Uses this function, and then we select the wells because there are lots of wells here. For example, I can do. If you would like to know what other wells in this data, you can use this df npd wellbore name, okay, dot unique. Okay, we have already covered this in our second session, how to print the individual well names. So this is our column name, and then we print this unique. So we get this all of these wells. But for this session, we only use this for F14. Okay, and then we select the F14, and then this is only our interest data of interest, and then we plot this data, and you can see here there are lots of outliers in our data. Okay, we have to remove the outliers. Okay, so it will make our data more smoother. Okay, we use this function remove outliers, and then we come up with this result. And in this code, actually, you can adjust with any number you'd like. So I suggest you start from small number, for example, 10 and 20, and then you increase it until you get a smooth curve. Okay, and then you pass the trim equals true, because if you don't, so maybe I will show you once again. If we pass it at false, okay, you see this initial decline, initial increase in the production, but you don't. But we will not use this for decline curve analysis because we are just analyzing the decline, not the increase in production. So we change it into true to remove this part. Okay. And then we simply do our decline curve analysis using this ARPS fit. Okay. So that's all for today for this session. I believe this is quite a short session because actually decline curve analysis is simple and you can use this function for your data. So maybe if you have any question, I have so far seen 8 questions coming in. So let's time for question and answer. So thank you for your attention.
Engineer Yohanes, thank you very much for this informative session. Thank you for the audience for watching. Now we're gonna take the most important questions. First question is, where can we get your decline analysis notebook?
Actually, um, yeah, I think sure you can get this notebook. Okay, I will upload this notebook. This is our notebook here. This is our previous sessions notebook. And then for the third and fourth session, I will upload it after this session. And I will maybe I'll upload in the Facebook group, or after the video has been uploaded in the YouTube, I will comment under the video. Maybe I think, is there any question for maybe like a bit technical for this session? Maybe like more about Python or about some
Yeah.
stuffs that we have already been
Yes,
discussing.
yes. So another question here, B is negative, but why decline curve is hyperbolic?
Oh yeah, that's a good question. That's a good question. Okay, so we are back to this formula. Okay, um, actually, if you can make your own function here. It is a hyperbolic function. You can make this function in this Python. Okay, so maybe for example, yeah, qi this b and 1 over b. I would like to make this function here hyperbolic def hyperbolic function. So I can make this function, but I have already have this in this program. So this is the function. We can copy and paste here. Okay. So if you want to try um, using a negative input, b as negative, you can um, you can investigate yourself. So you have, for example, time for 0 to maybe 1,000 days, and then you define qi di, and then you try b as negative. You will have that the result is also declining. But why negative? It's because, as we have already been discussed here, there is a control from the surface. What control? Once again, we just did water injection to the field. It means that it is logical that when we perturb or when we disturb condition in the subsurface with anything, for example, we inject something into the surface, it will change the subsurface condition. So the production will be changing, and then the nature of the decline will be changing. So because of that, the some parameters will be also changing. Okay, and then also for the case of unconventional shale reservoirs or any other unconventional reservoirs, it is really common to have B equals negative. Okay, actually, this is the ARP's decline curve. There are lots of decline curve theories. For example, the Duong theory, which is for the shale play, and then this one in my slide cover. This is another decline curve analysis. If you know Tom Blasingame, he is now the president of the SPE. Okay, so Tom Blasingame has this decline curve type. Okay, so this is also another type of decline curve analysis. Okay, so it can result negative. Okay, it can result negative for any other unconventional reservoir or any other reservoirs for any other condition.
Okay. Last question. Can you explain quickly, just by steps, how you made the arcs fit function?
Sure. Yeah. Okay. So yeah. Um, okay. So maybe I would like to simplify my explanation. Okay. So first of all, we have this production data. We have the Q and the T. Okay. So here we have Q, T, and Q. Okay. We have time, and then we have the production rate. Okay. Production rate. Okay. And the basis of decline curve analysis, as you guess, it is just the curve fitting. Okay. So you should know what is the meaning of linear regression and nonlinear regression, because that is a basic discussion in any engineering and science. So this is actually the practice of doing nonlinear regression. Okay, so this is decline curve analysis is actually the nonlinear regression. Okay, so why it is called the nonlinear regression? Why? Because the hyperbolic function, it is not linear. Okay, it has an exponent here, so it is considered as the nonlinear regression. Okay, and then um, we have already been discussed in the first session about the use of psi-p curve fit. Okay, so psi-p curve fit is it's a function to do nonlinear regression. Okay, so in our very first session, we have already discussed. We show you how to do a nonlinear regression. We make our own synthetic data, and then we do a curve fit, a nonlinear regression or the curve fitting. Okay, so it is just quite the same as we did here in this decline curve analysis. Okay, so we use this SciPy curve fit. Okay, for this decline curve analysis. Actually, there are lots of functions out there other than SciPy. For example, Gecko. Gecko is another library for um, Gecko Python. This is another library for nonlinear regression. Okay, so you can use any other libraries for nonlinear regression, but I prefer to use SciPy curve to do nonlinear regression. Okay, and then the next thing, okay. Oh, I forget to explain to you what is the RMSE. So I'll explain you after this. Okay, so and then after we have already been fitting our data with a nonlinear function. So we fit our data with hyperbolic function, okay? And then the output is, the first one is QI, okay? The second one is DI, and the third one is B, okay? So these are our parameters that we obtain from decline curve analysis. Okay, so basically, if you do this decline SciPy curve fit, it will show you these three parameters. Okay, just go to our first session notebook, and you will see how to do curve fitting with SciPy. So it is just similar, and then the most important thing you have to concern is what is called as the RMSE. Okay, RMSE is the error. Okay, so it is a metric. It is a metric. Okay, to measure the goodness of our fit. Okay, so you see here, this is our result of our decline curve analysis. Okay, you can see that this is perfect. The fit is very perfect. Okay, so so how do we know that our line is perfect with our data? We can measure our goodness of fit with this RMSE. Okay, so in this function, actually, it has already been calculating the RMSE, but the basis of measuring RMSE, it is just simple. Okay, so from the nonlinear regression, you have obtained this qi, di, and b. Okay, and then you go back to this function. You define this t as your production data, and then the qi, di, and b is the parameters we have already obtained from this function. Okay, and then if you run, you will have a y-fit. Okay, y-fit is the fitted our fitted data after we do the decline curve analysis. So we have this y-fit and y data. Okay, we have these two things. Okay, for these two things, how to calculate the error that we have. So RMSE, so maybe I can make a new function, def RMSE. This is the y data and y fit. Okay, and then first, so RMSE is the root mean squared error. Okay, so first you subtract the fit and then the data. Okay, and then you square it, and then you divide by the number of your observations. How many observations do I have here? Okay, so we have this data, df2, right? So this is our data, and how many observations we have? So this is our n of observations. Okay, so n equals 3065. Okay, and then after this, we square it. So sorry, we take a square root of this. So this is the function how to calculate the error of our regression. Okay, and then after we measure the error, so this is the error of our DCA 0.005. So this is the 0.005, and you can be certain that your decline curve analysis is you can trust with your result. So actually, there is a basis of this. Function. Okay, so because I cannot share the recipe on how to make this function. Okay, because it is not a simple one, but the basis is understandable. So I hope that you can understand the basis of how to make a function if you want to do it from scratch, uh, from step by step in Python. So maybe I have another question here from Ashish. I tried to do this code of my own, but it's not working. Can you explain me why it is not working? Okay, so maybe you can email me, and I'm free in LinkedIn if you want to contact me in LinkedIn. So if you want to show your code and then maybe some of your data, I can help as best as I can. And then maybe another question. Okay, so okay.
All the
Yeah, I
questions are
think yeah,
non-technical. So.
yeah. Yeah, actually, if you want to learn how to do decline curve analysis, maybe I will share you another material here for our closing. Um, I have a repository that is called Python Bootcamp for Geoengineers. Okay, so in this repository, you can find my previous course here. So you can find some courses on how to learn Python, and then basic well-log data analysis. And then here you can see the basic decline curve analysis. If you go here, okay, so you can learn how to do decline curve analysis really step by step, because at the time I have 3 hours, so I can explain it very detailed. But you can go here, and then also for this course, you can access the notebooks here. Okay, so you can go to this link, and then you can see this notebook for this from the first session and to the fourth session. Okay, so I think that's all for today. If you would like to still would like to in contact with me, or you would like to maybe ask about anything about Python or anything about machine learning or something, you can contact me in LinkedIn or in email. So maybe you can have my contact here. Okay, so you can go here and then you will see some repositories I have for lots of different things. And I hope that our previous 4 courses is useful for you for your next study or your work. So I just wish all the best for you all. Don't stop learning after this session. You have to explore and you have to try more and more. Don't stop for this session. You have to explore more ideas and do this and that with Python, because for me there is not there is nothing impossible to do with Python. If someone is asking, can I do something with Python? I say yes, you can do all of things with Python. So you just require to learn it constantly, and then you try to solve as many as problem as you want. So in the future, you can find that Python or any programming practice is useful for your future. Okay,
Well, thank you very, very much for your valuable time, Engineer Yohanes. Thank you again.
thank you.
Uh, Thank you. I would like to remind you that this session is being recorded and will be posted on PyPetro YouTube channel. Stay tuned for the other upcoming webinars by following Arab Oil and Gas Academy Facebook page. We wish you all the best of luck and a fruitful days till next time. Goodbye.
Thank you, Loma. Goodbye,
Thank
everyone.
you so much. Goodbye, everyone.